All right, welcome to Lab 1 of our sequence called Our Place in Space, making use of the Skynet Robotic Telescope Network. This lab is broken into two parts, which at your institution will probably be implemented as two separate weeks. In the first week, or the first part, you'll learn how to use Skynet, our image request system. And using Skynet, you'll observe many objects in the solar system and a few deep sky objects as well. The telescopes will go off, collect these images for you, and get them back to you. And then in the second part of the lab, week 2, you will learn to use Afterglow, which is image viewing and an image analysis software that my team has also developed. And you'll open up your images using Afterglow. You'll learn how to adjust the brightness and contrast to bring out different details in your image. You'll learn how to make a few fundamental measurements like sizes of objects, how to check these values, and how to identify different things in your images. Which moon is this? Where is the dwarf planet? Things of that nature. Okay, so basically in Lab 1, you're going to image a whole bunch of stuff, which is going to be fun, and you're going to develop this skill set, a toolkit that you can use and build upon as we go through the rest of the sequence. Now, beginning in Lab 2, for the rest of the sequence, we will be following what astronomers call the cosmic distance ladder. We'll begin close in on Earth scales and then work our way farther and farther out until we're encompassing the entire universe at the end of the lab sequence. Now, in this video, which is just an overview video, I'm just going to go through the instructions at the top of the lab. In subsequent videos, I'll describe what's in the background sections and the procedure sections, and then there are also video tutorials embedded in the labs that give you detailed instructions on how to do the various different tasks. Okay, so let's just go through the instructions at the top of the lab. These instructions may vary from institution to institution. This is just one example, but I think it's a pretty typical example of what you'll be seeing here. First, you see links. These are the overview videos that I just mentioned, and the first of which you're watching right now. Also, there's a reminder to read the background sections before beginning the lab. Don't just jump to the procedure sections and start doing the tasks. There's usually some important information in the background sections that you'll need to carry out the procedures. And also sometimes, not in this lab, but in other labs, sometimes there are points to be gained with small tasks in the background sections. Okay? Then after that, there'll be some further instructions. Usually, if you have to submit some observations for an upcoming lab, we'll put a reminder here. But in this lab, for Lab 1, there's just a note. And the note is you're going to be asked to observe many objects, planets, moons, dwarf planets, some deep sky objects, etc. And not all of them are observable at any given time of the year. It's because the sun brightens half the sky. And since we don't know in advance when you're going to be doing this lab, we can't tell in advance which objects are observable and which ones aren't. In the lab, you'll learn how to tell that for yourself, and you're only expected to observe the objects that are currently observable. And you're not expected to observe things that are too close to the sun to be observed. And what this means is it's impossible to get all of the points in Lab 1. I think Lab 1 is worth 130 some points, and you may get 70 or 80 of those points, and that may be a very good score. So don't worry when you see that percentage, and just keep in mind, not all of the objects were observable. That's understood by your instructor, and your instructor will figure out a good way to convert the points into a reasonable letter grade. Okay. After the note, we have instructions that are the same in each and every lab. And I'm not going to go through them in future labs, but let me go through them quickly now, because if you don't follow these instructions, you can lose a lot of points. So these are things you have to be careful about. First of all, is you're allowed to submit your work 100 times. Not just the whole lab, but each individual question. You can change your mind up to 100 times, which is more than you'll need. And so I encourage you to submit your work frequently. There's also a save button, and you can use that as many times as you want as well. but I encourage you to use the submit button instead of the save button, because some students, they use the save button and then they forget to submit. And if you don't press that submit button at least once at the very end, then your instructor won't get any of your responses. Now, if this does happen to you, if you find yourself in this boat, talk to your instructor, because there is a way for your instructor to submit your responses after the fact. But just safest if you use the submit button as you go. Now, the second point here is to submit your work frequently. As you're answering each question, add submit. If you let webassign sit for many hours, you're doing some work and then you go away and you come back, webassign can time out and it doesn't tell you that it's timed out. So you can end up completing the lab and you think you submitted, but webassign, their database, doesn't receive any of your answers because it had already timed out. So save the work as you're doing it, and if you're gone for a long time, you may want to log off and back on. The third point is only have one copy of webassign open at a time. Don't have it open in multiple browsers or in multiple tabs. That confuses webassign, and you can again lose your answers that way. So just one copy. The next couple points have to do about individual responses. For example, some of your responses will be short answers, words, but a lot of your responses will be numerical. And the rule of thumb is to use 3 significant digits. Not 3 decimal places, 3 significant digits. For example, 1.24 has 3 significant digits, even though it only has 2 decimal places. So always submit 3 significant digits unless otherwise specified. And some of the measurements you'll be making in some of these labs, only 1 or only 2 is necessary, and we point it out at that point. And the reason you have to do this is a lot of the numerical responses are auto-graded. And sometimes if you don't have enough significant digits, you can get something marked wrong. So you'll want to remember to do that. Also, some of the numerical responses will have to be in scientific notation. Astronomers deal with very big numbers and sometimes very small numbers, and we have to use scientific notation. webassign expects you to submit those numbers in this format. If it's some number times 10 to the minus 3, you would write E minus 3. Don't write it out like this over here. webassign will not know how to interpret that, and it will appear to us as if you didn't even answer. It will just leave it blank if you try to do something like that. Also, when submitting numerical responses, don't add the unit. The unit's usually written next to the box, the entry box anyway. Just put the number in there. Don't put any letters in there. Again, that will confuse webassign, and we won't see any answer in that case. Finally, you'll be uploading a lot of files. Some of these are going to be graphs. In later labs, some of them are just going to be the images that you take, as in the case of this lab. And when you upload those files and save those files, make sure you don't use any special or strange characters. webassign sometimes chokes on those. Just use normal, everyday characters, letters, numbers when naming your files that you're going to upload. Okay, that's it for this overview. In the next overview video, I'll go through the background sections of Lab 1.